Inscribed angles. Before we begin with the examples, let's take a look at a few vocab words. First, we're going to look at a chord. So a chord is a line segment connecting 2 points on a curve. And I did already label these for you, but this is what a chord looks like. It does not go through the center. So as you can see, the chord is from one side to the other side of the circle, not including the center. Next, we have what we called an inscribed angle. And an inscribed angle is an angle whose vertex is on the side of the circle and whose sides are chords of the circle. So I already highlighted one chord. This, of course, is another chord because it does not go through the center. And the inscribed angle is the angle that these two chords form. So it is labeled for you. I also just traced over that. An intercepted arc is an arc with endpoints on the sides of an inscribed angle and its other points in the interior of the angle. So the intercepted arc connects those two chords that form the inscribed angle. So all of these go together. You have your chords, you have your inscribed angle, you have your intercepted arc. They all fit together. So let's put these into use when we go through the examples. First, let's look at the inscribed angle theorem. This says if the angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So this right here is the intercepted arc. This here is your inscribed angle. The inscribed angle is half the measure of this arc. So when we look at the examples, the first one should be very straightforward and easy. Here's your intercepted arc. Here's your inscribed angle. If the measure of your arc is 136, then the measure of the inscribed angle is going to be half of that. So I'm going to write this out as the measure of angle D, that's this angle here, is equal to 1/2 times the measure of arc AB. And please make sure you get your notation right. If you're dealing with an angle, you use an angle sign. If you're dealing with an arc, you use an arc sign. So the measure of angle D is equal to 1/2. The measure of arc AB is 136. Therefore, the measure of angle D is equal to 68 degrees. And that would be your answer. For number 2, recall that the circle adds up to 360 degrees. So we have 100 degrees here, we have 136 degrees here. So this arc right here is what's left over. So I'm going to first start by finding my intercepted arc, and then I can find the measure of angle D. So the measure of arc AB is found by 360 for the total measure minus 100 minus 136. And that tells me that the measure of arc AB is equal to 124 degrees. That's this arc here, 124. So now if we're looking for the measure of angle D, we know that the measure of angle D, I'm going to skip writing out the notation, is 1/2 of my intercepted arc, which is 124 degrees. Therefore, the measure of angle D is equal to 62 degrees. Okay, next is number 3, which number 3 looks a bit more complicated, but we're looking to find, in this case, the arc. So we're not finding the inscribed angle, that's already given to us. So we're working backwards here. We're looking to find the measure of arc PO, which is actually double the degree measure of angle N. So I'm going to write 2 times 56. That's what you're doing. You're multiplying this angle by 2 to give you that angle measure. I'm sorry, that arc measure. And that tells us that that arc PO is equal to 112. Now, there's no other question with this example, but here you have 2 chords that form the intercepted arc I highlighted in green. But we also have another chord, or another set here, which forms another intercepted arc here. So I could also ask you what the measure of angle MPN, that's this angle right here. I could ask you that measure, and it would be half of 70, because that's the intercepted arc. So that would actually be 35 degrees. I know that's not the question there, but if it was, you could answer it that way. Okay, next we're looking at another statement that says if 2 inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So if I take a look at this diagram and I highlight my chords here and here, I can see that the intercepted arc is between the points D and A. Now, I also could highlight this chord, and those 2 chords also intercept the same arc. So you have 2 chords coming together to intercept an arc, and the same thing happens twice, and therefore these angles are considered to be congruent. So you could say angle C and angle B are congruent because of this theorem. Let's take a look at example set 2, where we're trying to find the measure of angle T. That would be right here. So I know that the measure of angle T is formed by these chords, and those 2 chords intercept this arc. I also see that I have these 2 chords that intercept the same arc. So I know that angle T and angle U are congruent. So knowing that those 2 chords are congruent, I can substitute in my expressions and I can solve for x. So I can write 3x minus 5 is equal to 2x plus 15. I'm going to subtract 2x from both sides. X minus 5 is equal to 15. Add 5 to both sides, and x is equal to 20. That's the value of x, but the directions tell us to find the measure of angle T. So now I'm going to take the fact that I know what x is, and I'm going to substitute it into the measure of angle T, which is equal to 3x minus 5. That means I'm replacing x with 20, giving me 3 times 20, which is 60, minus 5. And my final answer for the measure of angle T is equal to 55 degrees. Next, we're going to look at the statement that says an inscribed angle of a triangle intercepts a diameter or a semicircle if and only if the angle is a right angle, which is this angle here. So let's actually just jump right down and take a look at the examples and how we can utilize this. In number 1, there's actually a typo. You're not finding the measure of angle T, that does not exist. You're supposed to be finding the measure of angle H. Okay, so because we have a diameter right here, and we have a chord here, which forms our intercepted arc here, we know that this is going to be our right angle. Okay, so knowing that this is a right angle, we also can see that we have a triangle. This is a triangle, and triangles sum to 180 degrees on the interior. It's called the triangle angle sum theorem. So in order to solve for x and then in return solve for h, what we're going to do is we're going to add up the measure of angle F plus the measure of angle H plus the measure of angle G, and we know that these sum to 180 degrees. The measure of angle F is represented with the expression of 4x plus 2. H is represented with 9x minus 3, and G is 90 degrees. This sums to 180. When we combine like terms, we have 13x plus 89 is equal to 180. Subtract 89 from both sides, and we're left with 13x equals 91. And then we're left with x equals 7. Okay, our final question or our final answer should be the measure of angle H. So what I'm going to do to solve for the measure of angle H is I'm going to substitute x equals 7 back into the original expression for angle H. So the original expression is 9x minus 3. So we have 9 times 7 minus 3. That tells us that the measure of angle H is 63 minus 3, or 60 degrees. Okay, I want everyone to try number 2 by yourself. This one utilizes a few different properties that we have gone over. So first I want you to recognize if you have a diameter that could potentially form a right triangle within the circle. So maybe that one I just highlighted. But look over this, see what you can utilize. Do you have congruent angles? Maybe something like that. Press pause, try to complete this, and then come back together or come back to the video and watch my answer. And the last statement that we're going over with the last example set says, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Recall that supplementary means they sum to 180. Okay, so what this is saying is if you have a quadrilateral or a four-sided figure inside of a circle, opposite angles sum to 180 degrees. So the two ones I just identified in orange sum to 180, and then these two that I'm identifying in blue also sum to 180. They are not congruent, they just sum to 180. So if we scroll down and we look at an actual example, we know that if we have 60 degrees here, that this angle must sum to 180. Therefore, we know the measure of angle Z plus the measure of angle X is equal to 180. We know Z is 60 plus the measure of angle X is equal to 180. The measure of angle X is equal to 120 when you subtract 60 degrees from both sides. Now let's take a look at angle W. So if angle W is 95, we know that angle Y must make up our supplementary angle. So we know the measure of angle W plus the measure of angle Y is equal to 180. That tells us that 95 plus the measure of angle Y equals 180. Subtract 95 from both sides, and the measure of angle Y is equal to 85 degrees. And you can double check that, of course, by just substituting it back into a calculator and making sure that your two angles, such as 60 and 120, sum to 180. Okay, please let me know if you have any questions, and that's the end of the notes for today.